Okay, good afternoon, everyone. So let's start the talk right now. Is that okay, Dr. New? Okay. Okay, so good afternoon, everyone. Once again, thank you very much for taking your time, your precious time, to join this talk this afternoon. Before I invite Dr. New to begin her talk, let me just give a brief introduction about Dr. Neo. So Dr. Neo Hui Min graduated from Juntendo University, Tokyo in year 2007 with a PhD in medical sciences and specialized in bacteriology. And she is currently an associate professor and senior research fellow with UKM, Medical Molecular Biology Institute, or in short, UMBI, UKM. She was trained in the laboratory of Prof. Dr. Keiichi Hiramatsu in Juntendo University. The laboratory which reported, characterized, and whole genome sequence the world's first vancomycin intermediate Staphylococcus aureus, or in short, VISA, V-I-S-A. So Dr. Neo's research interests are in the field of staphylococci biology and also antimicrobial resistance. She's keen to learn how bacteria, especially methicillin-resistant Staphylococcus aureus, or MRSA in short, become resistant towards antibiotics and how they result in host colonization or infection. Dr. Neo has also been working with clinicians and microbiologists of Hospital Chancellor Tuanku Musris. Formerly, it was known as UKM Medical Center, to introduce usage of molecular typing for surveillance, infection tracking, and control of antimicrobial resistant bacterial pathogens in the hospital. So currently, she is leading a project to investigate the feasibility of using 16S rRNA metagenomics sequencing for pathogen identification in the hospital clinical microbiology laboratory. In addition, she is also actively involved in gut microbiome and sepsis research. Thus, we are very honored to have her today. Thank you very much, Dr. Neo, for spending your time and willing to be our speaker today. So today she will share more about the topics related to the phenomenon about antimicrobial resistance, which is AMR, in the title that you see in the slide. And she will also discuss on the factors leading towards AMR, together with current options that are employed to slow the emergence of resistant pathogens. In addition, thinking out of the box strategies to flatten the AMR curve will also be discussed. So without further ado, let's give a big round of applause virtually for Dr. Neo Hui Min. Hold on. To begin her talk. Yeah. And okay, and all the participants here, if you have any questions, you may always drop your questions at the Q&A boxes. Later, we will open up for a Q&A session. All right, so thank you very much. So now let's give the attention to Dr. Neo. Dr. Neo, please.
So good afternoon, everyone. I am Hui Min. Thank you very much, Dr. Saw, for the very kind introduction. Many thanks to UTAR for this opportunity to talk about antimicrobial resistance, the acronym AMR. So let me try to move the slides.
It's not moving?
Yeah, it's not. Okay, right. Okay, so, right. So I've been interested in AMR since high school, and I'm very fortunate to be able to do my PhD in Juntendo University, working on, as Dr. Saw mentioned just now, methicillin resistance, and also glycopeptide resistance in MRSA, and also now having a career working on several aspects of AMR with my wonderful students, support staff, mentors, and also collaborators. Now, before I go on, please allow me to state that antimicrobials are inclusive of all antibiotics, antivirals, antiparasitic agents, antifungals. But for the purpose of this talk, antimicrobial resistance will refer to the resistance for antibiotics. And that's the acronym I will use for this talk, AMR, for antibiotic resistance. Now, antibiotics are not new concepts. Our ancestors have been using ingredients such as honey, turmeric, when they have inflammation or cuts or wounds on their hands. So, but these early civilizations did not realize that it's actually the active compounds inside the food that kill the bacteria. Until Sir Alexander Fleming discovered and isolated penicillin from the mole, which is presented in the slide here, in 1928, on 28th September, which is this week, but 90 years ago, right? So penicillin was found, and then from then on, we usher in the golden era of antibiotic discovery, and from that, we thought that the curtain on infectious diseases is already closed, right? Nobody will suffer anymore from infections. However, as we know, life finds a way. Ironically, the usage of an antibiotic usually signifies the beginning of the end of the efficacy of the antibiotic itself. So in tandem with the era of the golden age of antibiotic discovery, we find that antibiotic-resistant pathogens are also slowly creeping up at the same time. And then to make matters worse, we have the problem of the drying antibiotic pipelines where pharmaceutical companies, many pharmaceutical companies left the antibiotic market. So we do not have much options now for antibiotics. So much so that in a 2014 report by the O'Neill committee to the UK government that time, they did the mathematical modeling, economic modeling, and they projected that we will have 10 million deaths due to an AMR every single year after the year 2050. Now we know that how many deaths from COVID until now? I think about it reached 1 million deaths. So there was COVID is less than 1 year. However, for AMR, it's projected that every year after 2050 we will have 10 million deaths every single year. So what did we do, what did we do to get here after the success of penicillin itself? Right, at the microscopic level, or I would say the molecular level, there will be selection pressure. Some bacteria are inherently resistant towards antibiotics. So when you give antibiotics, only the resistant bacteria will survive and all the other normal flora will be wiped out. Bacteria are also very good at sharing information. So they get a mutation, a gene transfer of antibiotic resistant genes, and they become resistant. Now, that was at the microscopic level. At the macroscopic level, we contributed to this scenario via inappropriate use of antibiotics. I've seen pharmacists selling antibiotics without any doctor's prescription. In Malaysia, we still need the prescription from doctors for antibiotics. So I've seen local pharmacies dispense antibiotics without any prescription. There are also the problem of inadequate diagnostics. We cannot catch resistant pathogens fast enough. So clinicians will always, to save the patient, they will administer broad spectrum antibiotics to the patient. Agricultural use, right? So with the discovery that you can use antibiotics to prevent our chickens from getting sick and then to have enough food for everyone, we find that there are AMR genes in our poultry. So yeah, we have enough food now, but are we sacrificing something bigger in the long run? Right, and then sanitation, and also economic hardship. Yeah, we are now very familiar with hand washing with social distancing and so on. But hand washing, good sanitation, and also social distancing is actually a luxury. For countries which can't practice this, of course, they will have very high COVID rates in comparison to COVID. But AMR is also a very big problem in countries that couldn't practice this sanitization, and also if they are facing economic hardship. And also, what about climate change? Is climate change driving antimicrobial resistance? Right. So with COVID, we find very interesting, how to say, scenarios in our everyday life now, because we find that the population, most of us now are very aware of infection. We're aware of sanitization. We're aware of what PPE means right now. Everybody knows what does PPE means compared to before COVID. And then even people know what is R0, right? So I think this sort of makes us in AMR just a little bit jealous, maybe, because yeah, COVID is a very important problem, but the problem with AMR is also because it's a slow motion pandemic, nobody really realized that it is creeping up, right? So I always put it as the frog in the boiling water scenario, right? We feel that, okay, yeah, the water is starting to get warm, but it's not really that warm yet. It's kind of quite comfortable. And yeah, we still have antibiotics, and don't worry, like there'll surely be new antibiotic discoveries, like surely there'll be a vaccine for COVID, right? So surely there'll be new antibiotics in the future. And then we do not press the panic button yet. But so when do we press it? And actually, how long do we have before we need to press it, right? So because COVID-19 really foretells what a world without antibiotics will be. Look what is happening to our schools. Look what is happening to our workplaces, our economy, our health system, right? So yeah, we can have lockdowns for COVID, but if there are no antibiotics, can we still safely have childbirth? Can we still safely extract our wisdom tooth, or have, simple surgeries such as appendectomy? Can you trust your children to go cycling? What if they have a fall and have this drug-resistant infection and there's no antibiotic around, right? So AMR undermines the efficacy of modern medicine that we know and enjoy today, so much so that we already take for granted of it, right? So what is being done, or what can be done? I will talk about the efforts in therapeutics development, in antimicrobial stewardship, and also infection control, surveillance, and awareness in our attempt to prevent the slow motion AMR pandemic. I will also share some fresh ideas on some alternative research that can be done on AMR, since Dr. Saw mentioned that some UTAR lecturers and researchers are also in this webinar. Right. So for new therapeutics, yeah, since there's a lack of antibiotics, so the solution naturally will be development of new antibiotics, right? So yeah, that is very, very true. And in fact, who has a list? The WHO has a list of the bacterial infections, which is in critical needs of new antibiotics, critical need high or medium, as you can see on this slide. And then if you're an antibiotic researcher and you're interested to know what are the options that we have in the pipeline, you can refer to this review article by Butler and Patterson. I think it was just out in 2020. And also you can always check into the Pew Charitable Trust website. They always have data on antibiotics currently in global clinical development. And they recently upgraded the website to have animated animation. I can't show it here on the slide, but if you check it out, and if you click on the left panel, which shows the year of filing for approval of the antibiotics, you can see by each year how many antibiotics were filed for approval, were approved, and were discontinued. And then when I was doing this screenshot, I clicked on 2019, and it showed that the total approved antibiotics since 2014 was only 14, right? And then total discontinued was 18. So we actually have a negative balance, right? So is it time to push the panic button yet? Right. So that is not to say that we do not have discovery of new molecules which can kill bacteria. Like, for example, this report from Princeton University, they found this antimicrobial molecule, which they term it as the poison arrow, where it acts by puncturing bacterial cells walls and releasing folate to kill the bacteria itself. Some cautiously optimistic news is that they cannot find induced resistance from the bacteria they tested to this molecule, so they name it resisting, right? And then following this, I also like to introduce some work from my previous PhD student. She's now a postdoc with Professor Long Zhu Chui, my mentor, in Jiqi Medical University. The group is working using the CRISPR-Cas13a system approach, where they found that CRISPR is the buzzword now every time, right? So everything is always CRISPR, CRISPR, CRISPR. So yeah, with this CRISPR, I find that it's very interesting. They managed to, the system can detect the presence of the AMR gene, and then after it detects it, then it selectively kills the cells harboring these genes. Yeah, sequence-specific killing, and then it kills regardless where the AMR gene is located on, whether it's on the plasmid or on the chromosome. So it's a very powerful, I would say a very powerful approach. And they've also tested it, and it worked in the animal model, not just in bacterial cells. So it worked in an in vivo model in the Galleria worm. If you want to check it out, it's a worm, Galleria. And then to me personally, the attractive part about this is that because it's very specific. So let's say if it can be an antibiotic, and then let's say you administer it to a patient, so it will not cause the collateral damage as our usual antibiotics, right? If we eat antibiotics, we always feel like, I don't know whether it's psychological, but we always feel like lethargic, and we also know that it will kill our normal flora, which are not resistant. So with this CRISPR-Cas13a, it doesn't, affect our normal flora, and so therefore it doesn't select for resistant bacteria. So I feel like this is a very interesting approach, which hopefully we can see it really is now still in the laboratory-based research. So hopefully we can see it really coming into the market and becoming a really effective antibiotic in the future. Of course, besides that, we have many different groups working on many approach for therapeutics. We have repurposing of old drugs like helicin, which was discovered by MIT researchers using artificial intelligence. Helicin was originally developed for diabetics, and then found that it's not so effective, but after using machine learning, we found that it can actually act as an antibiotic and kill bacterial cells. Phage therapy, vaccines, don't fall sick in the first place, so we developed vaccines, antibiofilms, nanomaterials, anti-infectives, whatnot. Anti-infectives is also something to look to, because I find that many researchers find that it only blocks the virulence, so it also gives less selective pressure on our normal flora. So many work on therapeutics. However, the cautious message here is that getting a new antibiotic into the market is not easy, right? From the initial molecule synthesis in the lab until selling in the market take around 10 years, if not mistaken, yes, with many valley of deaths, right? And then the thing with antibiotics too is not like drugs for cancer or drugs for diabetes. Cancer for drugs and diabetes, like doctors will want to prescribe new drugs, right, for the patients. Let's try out this new antihypertensive, or let's try out this new anti-cholesterol drug. But for antibiotics, doctors will always want to save the best for last, right? We try with the older drugs first. If they don't work, then we slowly try the new ones. I think, it's good because we want to prevent selection for resistance, but this is bad news for companies, right? Like if I'm a drug pharma company and you keep saving my drug for one day, so my revenue doesn't come in. So the antibiotic market pipeline, that's why I mentioned in my earlier slides, is drying up, because pharmaceutical companies need to have 10 years before they can have revenue on the drug. So this, fortunately, some organizations and governments really realize this. So this is a very interesting approach to the UK government, Sweden, and most recently USA, just I think yesterday or this week, they will attempt to try a new model for antibiotic market, in which their hospitals, government hospitals, will pay upfront investment, upfront money for the antibiotics. So it's kind of like Netflix, right, or prepaid. So we pay Netflix the same amount of money, right? Then if we view or don't view, it's up to us, right? So these three governments, they also plan to do the same thing for antibiotics. They will pay the company upfront for the value of the antibiotics. So this will ensure that these companies will, pharma companies, antibiotic companies will get their revenue and be able to stay, you know, to sustain their business and continue R&D on antibiotics. So hopefully this will fix the antibiotic pipeline, the Netflix model for antibiotics pipeline. And then also now we also have organizations and accelerators such as the CARP-X and also the AMR Action Fund. Antibiotic companies can apply for funding from these organizations and accelerators to invest in their drugs so that you know, we can have sustainable antibiotic development from the pharmaceutical companies. So optimistic news to look upon. This all actually just happened this year. So up till last year, many companies, a few companies were having bankruptcy. So this year, some action is being taken upon. So hopefully we'll have really new and sustainable drugs coming in into the future, right? If you're interested more into this, you can look into the global AMR R&D dynamic dashboard, right? You can see how many are in the clinical, how many antibiotics are in the clinical development and what are the incentives for it, so on and so forth. Now, we always say that drugs is important, but how to control the usage of drugs is also very, very important. And we have a term for it, which is stewardship. In hospitals, we do antimicrobial stewardship, or AMS. Now, in our hospital chancellor, Tuan Gu Mukris, we have been doing it since 2011, where the group will mostly consist of pharmacists. They will give guidelines to the clinicians on optimal antimicrobial prescribing, so that, you know, the antibiotics are not overprescribed, and then what is the best fit for purpose antibiotic? Only fit for purpose antibiotics are being prescribed. Now, for good stewardship, we will need to know how to say, we will need to detect antibiotic resistant pathogens early on, right, to enable good AMS. Now, in the traditional, or I would say the common antibiotic susceptibility tests carried out in hospital is based on the CLSI or the UCAS guidelines. We will expose the tested bacteria to antibiotics, and then we'll check the subsequent day if there are any growth, and then we'll report this to the clinician. Okay, if there's growth, then we cannot prescribe this antibiotic. No growth, then we can prescribe the antibiotic. Now, this time for this bacteria to grow over 1 day, right, will take around a turnaround time of at least 2 to 3 days, right? So this is not fast enough, because then clinician will sometimes be forced to give broad spectrum antibiotics to the patients, and this is what drives what has driven AMR in the first place. Now, there are some recent developments which I also feel this is very interesting, term it as the rapid antibiotic susceptibility test, where in this approach, yes, we also expose the tested pathogen to antibiotics, but you'll be able to monitor the growth of the pathogen in real time. So it's based on microscopy, so you can, or detection of nucleic acids, so you can see the bacteria dividing in real time, or their nucleic acids how to say, becoming more and more over time. And it's reported that I think some of some of the strategies using this between 2 to 4 hours, they can already inform the clinician on whether the antibiotic can be used for their patient. So this is definitely something to look forward to into the future, and we'll see how it goes. This is definitely a very good tool for AMS. For slow-growing bacteria, such as tuberculosis, the Mycobacterium tuberculosis, we probably could not employ the phenotype rapid phenotype antibiotic susceptibility tests to give rapid antibiotic prescription. But for this, we can use molecular diagnostics such as next generation sequencing or third generation sequencing, such as in the dplex TB kit, where patient only need to provide sputum when they come to the clinic, and then by the next visit, using next generation sequencing, we will be able to detect whether the patient has an infection of TB, and whether the TB, what AMR genes are the TB strain carrying. So then at the same time, you diagnose that the patient has TB, and also can give efficacious antibiotics to the patient as well. So this hopefully will also reduce the burden of TB, antibiotic-resistant TB infections. Right. So we talk about the drugs. We talk about controlling drugs. So how about controlling the pathogen itself? Right. So this is a small study we did in our hospital in 2012 to 2013 in the ICU of HCPM. We have always had MRSA strains in our ICU, and during that year we managed to get a small grant, which during that time we molecularly typed the MRSA, which was isolated in the ICU. Now this is the first time like we can identify, we can tell you like, okay, which hospital bed in the ICU and which patient carries which type of MRSA, and we can also tell the doctors like, okay, if there's any patient environment transmission of MRSA in the ICU itself. We managed to identify 2 clones, and we also identified the beds in the ICU which has these clones. So this is very interesting study. However, because we have a change in the management of the infection control team, so we could not continue it. So, but from this experience, it's also taught me the importance, if you want to do AMR in the clinical setting, we really need to have the buy-in from the stakeholders, and in many cases, it's the hospital management. We recently have a new infection control doctor, so we hope to continue this, not just for MRSA, but also for the carbapenem-resistant Enterobacteriaceae. So that was only for one pathogen, which is MRSA. What about if we try to profile the AMR bacterial community in a hospital? Now, the Tan Tock Seng Hospital in Singapore did just that. This was also published recently. They used the metagenomics to profile all the AMR pathogens in various locations of their hospital. And this is just a discovery study. So from that report, they find that, of course, they do have AMR pathogen clusters in the hospital. And the worrying thing is that even with proper cleaning, these AMR pathogen clusters are still stable throughout time. So yes, it's still worrying, but at least now we know that we have a way to know that they are there, and the subsequent path will be to perhaps identify the source and eradicate it. So we plan to do just that. We obtained another small grant from to profile the metagenome of our own hospital. We selected 3 wards to do it. I think the surgical ward, medical ward, and I think the ICU. So with that, we will identify the patient environment transmission, and we aim to go beyond that, which is to identify the source of these AMR pathogens and also do source eradication. Infection control is important, and so is monitoring, which is to monitor the trends of the isolation of AMR pathogens over time. Now, due to the impeding AMR threat, the WHO launched the Global AMR Surveillance System, we call it GLASS, in 2015. So for this initiative, member countries are encouraged to submit the data on their AMR pathogens, whether they are how many are resistant, how many are sensitive to WHO. So this allows the international body to monitor AMR trends, to detect any emerging AMR patterns, and to hopefully reduce the AMR burden. So surveillance of AMR pathogens are also done by many organizations, including this one is by CEDRIC. It's a non-profit organization funded by the Wellcome Trust. And for locally, we ourselves, we also attempted to do the MRSA molecular surveillance in our hospital. That you will notice is that mostly it's all MRSA because I was trained in MRSA. So we started with this one. So this we initiated the first surveillance in 2009. And I'm very fortunate to get another grant, convince the hospital to give us another grant in 2017 to revisit the surveillance, because surveillance we have to do periodically. It cannot be just a one-off surveillance to really harness the benefit from it. So this is a collaborative effort between UMBI, the infection control of the hospital, and also the Department of Medical Microbiology and Immunology of the Faculty of Medicine. And this time we also go beyond bacterial identification, go beyond the antibiotic susceptibility stability testing, we identified the genotype of MRSA strains circulating in our hospital. We typed the resistant determinants. In this case, it's at the SCC-MAC type, and also the virulence genes. And you can see from the slide, this is also a discovery for us because we did the first surveillance in 2009. We found that it's a hospital. Most of the strains are hospital acquired, which is the SCC-MAC type 3. If you're working on MRSA, you will know what is SCC-MAC type 3. And then in 2017, surprisingly, 99%, more than 90% of the MRSA strains have changed their clonotype to the community acquired, which is SCC-MAC type 4. Now, the toxin gene, biotoxin gene typing, we also found that they have a change in the toxin gene profile. And then interestingly, now this one is also something a discovery for us. We found that the strains that we have now actually grows very much faster than the original strain we have in 2009. Now imagine if we are just culturing the MRSA on the culture plates, we would not know that there's this, silently this MRSA have changed under our nose. So this is something which we are pursuing on, and we managed to get another grant from the university to continue another surveillance and also to perform whole genome surveillance, which actually this has been done in the Philippines for the carbapenem-resistant pathogens in 2013 to 2014. And with this whole genome sequencing of these 4 pathogens, they can identify what are the AMR genes, what are the AMR strains, what are the genes that they are carrying, and also the plasmids that they are carrying, because this one is from carbapenem resistant. What are the resistant plasmids they are carrying? And with that, have this system of continuous monitoring. So I feel that this is very impressive for Philippines, and I hope that in Malaysia we can set something up like that, because actually GLASS is also going towards that. As I mentioned just now, we are now encouraged to submit our antimicro AMR data, but it's just whether how resistant, how many percent, susceptible, how many percent. But GLASS is also this year, this is just out. It came up with a technical note on whole genome sequencing of AMR pathogens. So I think this is good news for the sequencing companies probably. So yeah, more I foresee that many more the MOH will start the sequencing initiatives on the pathogens, and with that we can hopefully know more about our AMR pathogens and really be on track to know that they are changing and not be, have this sudden attack where we don't know if they really changed and something like that. So this is on surveillance, and I think the ultimate aim would be have something like the resistance map. You can click on this too in the internet. This is managed by CDAP, and where they plot on the world map on the resistant rates of a particular country. You can explore by country. You can explore antibiotic use of the country as well. This is based on data they collect, and they put it on an interactive map. Like when I screenshot, this is on antibiotic resistance of E. coli in Malaysia. So you can see most of our strains of E. coli strains are already resistant to the common penicillins in Malaysia. Right, you can further click on the other bacteria that is located in the website itself and see how the AMR rates are in our country. So that was on surveillance control. We talk about drugs, we talk about the bugs. So what about the humans, right? Because as I mentioned just now, microscopically resistant, yes. Macroscopically, a lot of factors is actually driving AMR. So what about changing our behavior, right? We find that in the recent COVID-19, our behavior changed pretty quickly, right? We now know how to practice social distancing. We adapt pretty fast to the new normal. Now, what about AMR, right? So the message to get people alert about AMR is always this kind of apocalyptic message, which I presented just now, right? How many people will die in 2050, right? But in a recent research by the Wellcome Trust, they find that talking about isn't really alerting people about the AMR threat, and they recommend, the researchers in this research recommend that we should tell people how important antibiotics are, like to them individually. Like as I mentioned just now, can you safely go for have a child, or go for wisdom tooth extraction? This kind of normal things which we do or we enjoy without any worry will once again become life-threatening if there are no more effective antibiotics, right? So Wellcome Trust researchers encourage us to talk about antibiotics in this way, like lockdown can prevent. There's a rumor about the second lockdown, right? So lockdown can slow down or prevent SARS-CoV-2, right? But during lockdowns, you still have child delivery, right? Then you still need to go for appendectomies if there's an emergency. So with that, you can't prevent, lockdown can't prevent antibiotic resistance, because antibiotics will still be prescribed, and perhaps even more, right? So we are encouraged to really create this awareness about the AMR problem. And for me myself, I'm trying out this small initiative on what me myself as a researcher can do. Last year, I did some science communication to high schools, and this year was fortunate to receive a small grant, just a small grant from UNESCO. So I'll be conducting online science communication AMR awareness on AMR awareness to high school students, and also to senior citizens. Hopefully, I hope to keep on doing this yearly to really create awareness, and then to foster this, antibiotic guardians in our society. So this is what me myself as an AMR researcher, I feel that is what I can do. So the strategies that I mentioned just now, from therapeutics to control to surveillance to creating awareness, now all of them are important. But in the aspect of health economics now, the money that we spend for prevention and control compared to the money we spend to develop new antibiotics, now in the sense of health economics, of course, surveillance, stewardship, and awareness, we don't need to spend that much, and we can achieve control of AMR compared to the amount of money. Remember, we need 8 to 10 years before you can see development of antibiotics. So the amount, the cost to prevent AMR is much lower if we employ the proactive approach of a surveillance, stewardship, and awareness compared to developing new therapeutics or salvaging AMR, right? And I think we do not want to go there, right? So especially in the case of lower and middle income countries, right? And then, yeah, right. So I would like to spend the next couple of minutes, just a short time, to touch about fresh ideas for AMR research. So for the strategies that I mentioned just now, I think active research are being carried out. While preparing this talk, I come across some fresh ideas, which maybe for grant applications in future for our researchers. Right, I found this really interesting citizen science approach. You can check out the Tiny Earth or the ILIAP, the Liverpool School of Tropical Medicine projects, where they encourage their citizens, their school children to go all out to the environment to send swabs of the environment, from their driveway, from the garden, from the pond, and to send it to them, and they will screen if the samples that they send from the environment contain any potential and molecules to be developed as antibiotics. So I believe those who are working on phage research, they are actively doing these. If you're interested in phage research, you can look into the phage directory. It's an introduction of various labs across in the world dealing with phages. And I believe also this is a really good strategy. I'll just talk about the BCM, the Baylor College of Medicine, the Taylor Group of phages in BCM in Texas. So what they do is like a precision medicine approach towards AMR, which is really cool. The clinician that they work with, they will send samples if their patient have any AMR samples, and all antibiotics cannot work. They will send samples to this Taylor group, and what Taylor does is they will find phages which can respond to this bacteria, and then grow and purify the phages, characterize and ensure safety and sterility. They even prepared the FDA approval for compassionate use, and then ship them to the clinician to be used for these untreatable infections. So I feel like this is a really very good initiative, and Taylor itself is not for profit, and really look forward to many more initiatives like this in the future to solve AMR. Right. And then, yes, AMR is not just in humans, right? We have the tricycle launched by the WHO, which is only on the ESBL E. coli. Malaysia is participating in it. So it looks for ESBL E. coli in food, in poultry, and also in the environment. Now for the, during COVID, yeah, I think it's very good that we have, it's not good that we have COVID, but because of COVID, we can actually compare what things are being done for COVID, and also what are we currently doing for AMR. Now with COVID, we found that there are researchers who found the virus called SARS-CoV-2 virus in sewerage, right, in wastewater, and they say that this can be a surveillance system for which cities might have COVID, a high prevalence of COVID, and actually this probably could be done for AMR too, right? You have a surveillance of the wastewater, and you can know, you can actually detect and probably suspect if there are like high AMR, presence of AMR genes in wastewater, probably there's going to be high AMR incidence infection too in that particular area, right? So the WHO launched the WASH, water sanitation and hygiene, wastewater management technical note also this year, right? And then I think perhaps future research we can detect. Actually, do we have a lot of AMR genes, materials in the environment? And then when I was preparing for this and I searched the internet, I saw that there are actually groups, many engineering groups, they're actually working on wastewater treatment, and and there's this group from the NanoCat UM where they are trying to remove antibiotics from wastewater. So actually, yes, there are antibiotics in wastewater, just that where is the data? How is the prevalence like? I think we still do not have that in a very comprehensive manner, and probably is an area for future research or surveillance to do later. Right, and then can economic hardship cause AMR? I think that's also something to explore, right? Because we know that, yeah, you need, we mentioned that you have water, have good sanitation is important to prevent SARS-CoV-2. So what about AMR infections, right? And then climate change, as I mentioned just now, I think this is also very interesting. Some just very little reports have started to surface to say that yes, climate change, increase in global temperatures do cause the changes in our bacterial friends, and probably there will be an association between AMR and also climate change. So this is also a potential area to be researched upon, I think. And then post-COVID-19 and AMR, right? Before COVID, how was it? After COVID, how was it? So we have use of antibiotics for secondary bacterial lung infection. Will there be a spike in AMR cases in our country? Because it has been reported in other countries. In Malaysia, we still do not have the data. So yeah, people have been asking me, use so much hand sanitizers, will there be a change of normal flora and then the AMR pathogens will take over? Well, we don't know. Increase awareness of hygiene, right? I think this is something good that if we're doing in the social science aspect of AMR, yeah, now we have a better awareness of hygiene. So hopefully AMR will also come down. Well, we don't know. So a future potential research area, right? So the take-home message from this is that AMR doesn't only affects the sustainable development goal of number 3, good health and well-being, but it also is associated with poverty, with hunger, with economic growth. We know now, right? It's definitely when there's a pandemic, economic growth will suffer, right? And then also inequalities, right? When you have, let's say for COVID-19 again, you have vaccines, who will get it? And in a world without antibiotics, if there's a new development of antibiotics, who will get it, right? So when we prevent the AMR, when we have put an effort to prevent AMR, we are actually also contributing towards the achievement of the other SDGs other than SDGs number 3. Right. So if you want to know how a post-antibiotic world will look like, do have a look at this movie. It's only 20 minutes online. You can catch the movie. It's called Catch, and it gives you a very good scenario. What will we do without antibiotics? And I'll spend the last minute of my talk to promote about the World Antimicrobial Awareness Week in 2020. It's held every year from 18 to 24th November. And please use this chance to really tell someone about the importance of antibiotics, because antibiotics is very precious resource. It's just like water. It's just like our forests. We should all do our role to preserve this important resource for humanity. And as Professor Hannah from the WHO said, like, we prescribe a hypertensive drug, you only affect that particular person. But if you prescribe an antibiotic, you actually affect a whole community. And I think that's a very, very strong message. So let's work together to stay ahead of the AMR curve. Thank you so much for your kind attention, and let's prevent the AMR slow motion pandemic together. Thank you so much for your kind attention during this talk. Thank you, and back to you, Dr. Saw.
Okay, thank you very much, Dr. Neo, for the informative talk today. So now I invite the floor to pose any questions, or if you want, you can unmute your mic and ask questions to Dr. Neo if you have any. I have received some questions as well. Probably I can start first, yeah. Okay, so Dr. Neo, can I ask, you mentioned that the effort for MRSA genome surveillance for your hospital. Can you tell us more about this?
Yeah, when I came back from Juntando in 2008, yeah, it's not surprising that for us here in at least in our hospital, actually, we are still not using molecular techniques to characterize our pathogens, and because it's something I knew I learned during my PhD. So I managed to convince and get the agreement from the clinicians, microbiologists, to characterize, starting with MRSA, how to say, to molecularly type them. So as I presented in the slides just now, we now know how many clones are there in our hospital, right? And now I can tell you, okay, which clone behaves, how does the different clones behave. And because in the early days, we were just typing certain genes, actually only the virulence gene and also the SCC-MEC cassette, which confers methicillin resistance. We are now aiming towards whole genome sequencing surveillance. Hopefully we managed to get the money for the first to carry out the surveillance for selected strains from 2005 until 2017, which hopefully we will be able to send this to subject the strains to sequencing by this year. And then hopefully with that, we can know more about our strains, our MRSA strains, and to further convince the hospital management to fund surveillance. And MRSA is, I would say, is a small success story for us, because we managed to do quite a lot of work on it. And then now we have the infection control doctor to ask us to help to do together the typing for CRE, because the carbapenem-resistant Enterobacteriaceae is also a rising problem in HCTM. So we will see how it goes, and I'm pretty optimistic that as long as we have the support, funding support, and the buy-in from the stakeholders, which is the clinician, we will be able to do more, and to really archive our information, and then be prepared for, to be prepared and prevent really spike in AMR infections in HCTM.
Okay, great. But by the way, what are the common AMR pathogens in Malaysia?
If not mistaken,
like
MRSA is one, Staphylococcus is one. For gram-positive, is Staph aureus and also strep pneumonia. This is the data which I saw just now from the resistance map which I presented just now. And then from the GLASS report, we also see, besides Staphylococcus aureus and Staph pneumo, we have the acinital definitely on the rise. So if you're working on Acinetobacter, it's on the rise. E. coli and Klebsiella pneumonia, ESBL carrying E. coli and Klebsiella pneumonia, Salmonella, and also gonorrhea, Neisseria gonorrhea is also being monitored. So these are the few usual suspects of AMR pathogens for bacteria that I think is a concern in Malaysia.
I believe MTB as well, yeah, right now.
Yes. But in the GLASS report, the MTB, they didn't put it as a high burden, but maybe because due to not enough surveillance, because Dr. Saw, you're working on TB, so.
His GR is reported, I think, a few years back. But yeah, that's the concern right now anyway. Right. Are there new antibiotics being developed in Malaysia? New antibiotics that we are.
We see that just now all the initiatives that all the concern about the pharma companies going bankrupt, those are always the AMR companies, right? Like from UK or US or non-Malaysian companies. Probably because as far as I know, our pharma companies are local pharma companies such as COVID. I think they are more into the developing generic drugs. So once the patent from, let's say, GSK or Pfizer is completed, then our local companies will how to say, develop the generics for it. So much so that GSK and Pfizer, those are, before this initiative came out this year, they are already trying to leave the antibiotic market because they know that once the patent harvest, they also finish the revenue because the generic market is there. So as far as I know, we have many researchers, I think, working on new molecules, right? We are also isolating here and there for new molecules, but probably because we are researchers in the university. So as far as I know, I haven't seen any effort to really bring a molecule from the university lab or organization lab until the market level, right? Probably also because, and then for researchers, our funding is only 3 years. After that, habis cerita.
That's the sad thing, though. I mean, in research, if you have run out of money, that's another issue.
Yeah, right? I need to add that one into the slide. Yeah, we need to fix the funding system.
Yeah. So. All right. Thank you so much, Dr. Neo. I'm so sorry. Okay, the participants can't speak. Yeah, sorry about that. But if you have any questions, you can always go into the Q&A box. Yeah, under the box here, you can type in your questions. I actually have one question from Alexander. Yeah, the participants. But okay, it's a bit, okay, he was asking about the COVID-19. I'm not sure whether this is relevant, but okay, one question that he asked, is there any proven method to reduce the MRSA superbug resistance? Method to reduce MRSA superbug resistance. Can you reduce the resistance of the bacteria? I mean, I think antibiotic is by reduction of the usage of antibiotics or not overuse of the antibiotics. But any proven method?
Speaking from MRSA, if we are talking about methicillin resistance, I mean, most of the strains are now for MRSA itself. If the drug to be used is vancomycin, right? That's the first line drug, and it has been. If you're an MRSA fan or working with MRSA, you also heard about this hetero vancomycin resistance, which has been reported that it's actually due to the widespread usage of beta-lactams and also vancomycin, which caused the emergence of these VISA. Just now Dr. Saw mentioned, right, the VISA strains. So to reduce the occurrence. Most probably reduction of this usage of the antibiotic will help, but if you have a patient which needs the drug, then I think we have to have good antimicrobial stewardship, meaning continuous monitoring of the usage of the drug, because I did for my PhD, I've reading through the clinical reports, you can find that, yeah, maybe, I mean, surgeons, they are busy people, so they will start the drug and then continuous on, even though the patient is, the fever, everything have already come down, the drug is still being used. So yeah, and antimicrobial stewardship is a way to prevent further occurrence of resistance. And then I think also to effective control, sanitization procedures, cleaning procedures in the hospital. Also, you prevent, when we have good cleaning schedules, we also prevent the AMR pathogens from harboring in certain nooks and crevices of our hospital itself. So I think it's a multi-pronged approach, right? I hope I answered that question. If not, feel free to contact me again. Feel free to contact me by email.
Coming to that, yeah, Dr. Neo, so our local hospital, do they have sufficient level of healthcare setting to prevent nosocomial infection? This is from Alexander.
Again, so
our local hospital setup, is it good enough to prevent the nosocomial infection?
I would say good enough. It's just that you know, we are all humans, so we need constant reminder. Like masks, I think COVID is a very good, really very good example, right? We managed to bring it down, but due to carelessness, or like we feel that it's already gone, so the cases are up there. So I think our hospitals are fully equipped to control infection, but yeah, like hand washing of staffs, but because nurses and doctors, they are very busy, so you need to have, once it's always like that, when you have this hand washing campaign, you find that the rates of infection will drop, but after that yeah, so COVID-19 is a very good example to see what will happen, if AMR runs amok.
All right, and okay, and Dr. Chow here, Dr. Chow Lai, he asked, speaking on stewardship, do you now, what are the regulations in place at private clinics in Malaysia to prevent over-prescribing antibiotics to patients? Do you know any of the regulations or checkpoints or audits?
As far as I know, the each AMS team of each hospital have their own guidelines, if not mistaken, because our hospital have their own guideline on the stewardship of the antibiotics. I presume the private hospitals will also have that, because with AMR, how to say, many of the many pharmacists are aware of it now. So I presume that most hospitals will have the AMS guideline, but I do not think there's a national antibiotic policy, but not the prescription for, the general prescription for all hospitals. I don't think there is one, but I can check it up and confirm with you again. Yeah.
Okay. And from Zay here, UKM is listed in Tiny Earth Partner Instructor Network. So he wants to know, what is the university's role in the organization, and are there any similar efforts in Malaysia students can get involved in? Rosine is very interested into that.
Yeah, I don't think we are together with Tiny Earth. I don't think, I'm not sure if my colleagues, but I haven't, I talked to some people working in AMR in UKM before, but I don't think they are involved with Tiny Earth. And I do agree, it's a very interesting initiative, because when I found it while researching on AMR, I found that it's really, Tiny Earth is I think it's one of the most successful citizen science project. The other one, Iliad, if you managed to capture my screen just now, Iliad was not successful, and it's also, I think, based in one of the universities. So the universities, as usual, this is also funding oriented, so the university terminated the funding. Liverpool, the initiative by Liverpool, I think is still ongoing. UKM, as far as I know, we are not doing it yet. But if you feel interested, and if you feel that if there's anything we can work together on, yeah, I
Send an
personally feel
email.
when I talk to when I'm going to have the online seminar this year, I'm going to like talk to the high school and say like, okay, if any school is interested, let's try this out and see. Yeah. And in fact, actually, there's one antibiotic. I can't recall the name, but it's actually discovered via this type of citizen science project, right?
Okay, great. Zane, I hope we answered, Dr. Neo answered your question.
Yeah, please feel free to contact me if you feel I haven't answered any question like 100%, or if you feel you need more information, you can contact me.
No, can always write the email, show in the slide here. And one more question from Melissa. Are there any plan to improve the awareness and understanding of antimicrobial resistance through education? Campaign like Fight AMR, Safe Medicine for our children.
Yes. For me, myself, I've mentioned about the awareness campaign that I plan to do. So far, because I started doing it last year and I haven't, and WHO actually has this screen where you can report the activities you're going to do on AMR awareness. So far last year, I didn't see any other organization doing it yet. So I feel that if you're interested and like just give it a go, and if there's anything I can help with, just let me know, because I also did it on own initiative, because I feel that we really need to communicate this importance to the general public. And it's interesting that let me share this small experience if I have some time. It was during this Chinese New Year reunion dinner that I was with my relatives, and then we were just like, I just asked them like, oh, what do you know about antibiotic resistance? I was just asking my relatives, and I got two answers which immediately encouraged me to take action. The first one was one of my aunties said that, oh, I never finished my antibiotics, which was a shock to me, who always visit her every month, and I just got to realize that. And then another of my cousin brother
to finish them,
never finish antibiotics, And then my cousin brother said like, oh, I always go for antibiotics. I will ask my GP to prescribe antibiotics because then I can go back to work faster. This was also a shock to me. So I feel you don't need to have to wait for any campaign or proper things to do it. Like if you feel, there are a lot of information on the web. So feel, as long as our information is based on, especially the WHO, is definitely correct. You just need to tell people like, when you have finish antibiotics, don't buy antibiotics on your own, or don't save it for your children later. And then try to prevent from getting sick in the first place. This is the three steps which are continuously emphasized by WHO. And if we can really tell people that we care about, about these three steps, we are really contributing towards it. For official campaign, not that I know of.
Adding to that, Dr. Neo, actually, Melissa, we, just now Dr. Neo mentioned about the World
Awareness Week,
Antibiotics Awareness day, which is happening end of October, right?
November.
Oh, November, sorry, end of November. In the university, we do have post out all the posters, and then and some exhibitions to do.
Oh, that's great.
To support the campaign. That was last year, so this year was like because MCO and all this. So
because of COVID.
But but we do have this kind of campaign actually to create awareness, starting from the university itself.
When you mentioned that, I remember. Now coming to think of it, yes, our hospital also, they will have this campaign about the awareness, but it's mostly during that antibiotic awareness week. Yes. Right.
So, you can check it out from the website.
Oh, that's great. That's great to know that.
Okay, great. Any more questions from the floor? It's already past 10 minutes.
Oh, okay.
But thank you very much, Dr. Neo, for sharing all these very interesting information.
Thank you very much to Dr. Saw and to also the participants. Yeah.
Yes, to all the participants who spent time here. Again, if you don't have any more questions, I think we shall end the talk for today. Thank you once again, Dr. Neil. Thank you very much. And thank you to all participants who have participated. And again, Utah staff and students, if you want to claim some points, yeah, TPD points, please click into the link, yeah, on the chat box, and you have to sign in and sign up, yeah, to record that. Okay, so if there's no more questions, I think we shall end now. Thank you very much, everyone. Stay safe.
Stay safe.